Hello everyone and welcome back to another minute concept, this time about limits and continuity for basic calculus. So, limits and continuity, limits are related to the concept of continuity of functions, and continuity is basically the property of a graph for it to be able to be traced without lifting your pen. That's like the most basic definition. So for example, if we had a line like this and we had a point that we wanted to investigate for continuity such that it's over here, if we can trace our line all the way there, like without lifting our pen, we can actually draw the straight line like that. That means that it's continuous. However, of course, it's different when the situation on the point is something like this. There's going to be a hollow point in the middle. When there's a hollow point, you can't just pass through it, it's hollow, so you have to go from the other side. Now, that means there's a discontinuity. So there are three types of discontinuity. By analyzing a graph, you can actually identify them really easily. So the one that I just showed you guys, the one about the whole discontinuity, it's actually, as the name suggests, a whole discontinuity. So if we had any line here or any graph that has a hole in the middle, this is what we call a removable discontinuity. And because of the hole, it's also been called a whole discontinuity. Now, there's also another type of graph where you can have two different types of lines that don't really match. So for example, there's one line that goes over here and there's another line right on top of it that's shaded and goes to the opposite direction. Now, this is what we call a jump discontinuity or an essential discontinuity. And lastly, we also have our infinite discontinuities, which essentially looks like this. When two sides of the function go infinitely in opposite directions in terms of an asymptote. Now, there is a test for identifying these types of discontinuities. The test is what we call the three-step discontinuity test, which is described by these three conditions. Again, just like the last few videos, this might take a little longer for our minute concept, but this should cover pretty much everything that you guys need to know about this topic. So, for the three-step continuity test, there are three conditions that need to be satisfied. First, the function value at x needs to exist. So, for example, if we're investigating this point, it needs to be shaded. It needs to exist. Now, next is the limit as x approaches, a certain value. Okay, let's say that this is a, by the way. Let's make this a, just so that we can be consistent. The limit as x approaches a of f of x must also exist. And lastly, these must be equal. So f of a and the limit as x approaches a of f of x, must be equal. That's always a must. And the giveaways are this. If the first one is unsatisfied, then it's removable. If the second one is unsatisfied but the first is satisfied, then that means it's a jump. If the third is not satisfied, that means it's possibly an infinite, though these two not being satisfied are already signs that this is also going to fail. The third one is essentially just a descriptor as well to whether or not it's going to be infinitely discontinuous. So pretty much these first two conditions are what you need to be paying attention to. And in getting that, it's pretty simple. Just do the process of getting the limit as well as evaluating the function. Again, when evaluating a function, do not factor, and for limits you can factor. So there you go. So again, to recap this minute concept, basically there are three types of discontinuity. There's removable or whole discontinuity, which happens when the function value does not exist. There's also jump discontinuity, which is also known as the essential discontinuity, when the limits of the left and the right do not match, therefore the limit as x approaches a certain number does not exist, which is condition number 2. And the third one is infinite discontinuity, where pretty much everything is violated. There is no function value, the limit as well does not exist, and they're obviously both unequal. So thank you everyone for watching this minute concept. I hope you guys picked up something from this slightly short topic, limits and continuity. It's quite simple. You can test different examples that we have throughout this topic to see if they're continuous or not, and you will be able to tell, of course, if we get a DNE in our examples in the other videos and etc. So there you go. Thank you everyone for watching, and I hope you guys learned something, and good luck with anything that you guys have. Goodbye.